哎，好，哎，等一下啊，谢谢。I can read this meme. Do you understand this meme or not? Get this meme? David and Xavier is the same guy. Okay, good evening again. Excuse me. Good evening to all. There's something I want to announce first before we start. So I recruited one person to help me to type the lecture note. Hopefully this will help you to read the lecture notes. I posted on Moodles and you can look at, so if you look at the resources, right? The first thing in the resources is this typeset lecture notes. So you can refer that to, yeah. So you'll be update following my lecture note as well. Okay. So Eric, help me to type that. So I think we can recruit more person. Okay. So if you are interested, contact me. Please contact me. So maybe we form a team. Okay. To do this thing because when times go on, I think material getting more and more involved. And also your time may be getting less and less because you have assessment. So we can divide up our jobs. And second thing to form a team is because we can do quality control. So within our team, maybe we can check each other work and then see how we can make this lecture notes better. Okay. Obviously, all of you, when you read it, right, if you've seen all your typo, maybe this sentence doesn't make sense, you can give input also, and then we can do adjustment. Does it make sense? Okay. Yeah. Thank you, Eric, for starting this thing. Okay, so if you are good in latex or you want to learn latex, maybe you can join us. So these are basically the lecture 1 and 2 content. Yeah. So one good thing about this typeset thing is we have a numbering here. So in future, when we use a theorem from previous theorem, maybe we can do a reference inside our proof so that when you can click the hyperlink and then you will know which theorem we are using. Okay, because in my lecture notes, I typically don't put labeling of theorem. And there's a very good reason I do that also. First of all is whenever I use a theorem, right, it won't be too far away. Okay, it won't be too far from where I introduce it. Let's say if in lecture 10, I want to use a lecture 1 theorem, maybe I will specify, that's from lecture 1. But if it's from lecture 8 and 9, somehow I expect you to keep that theorem in your mind. Otherwise, it's also very hard for you. Okay. So please try make these theorem how to say natural to you. Natural to you. Okay. 对你会比较自然。Okay. 天天用的那种。So if you have started, how many of you started your assignment yet already? How many of you? Can I see? Have you started? Started? Tried? Okay. So actually a few of you are quite good. 5 of you, around 5 of you came for the office hour yesterday. 5 of you, 4 of you, 4 of you, right? Come to the office hour yesterday to get help for the assignment. Okay. So if you have problems, don't know how to do, come for the office hour. Okay, Tuesday 2 to 4, Wednesday 3 to 5. And I will be there, and there will be some of the seniors there also. So they know what I want. They went through my courses before. Okay. So they will be also there to help you. Okay, please get help. Yeah, anything you want to ask from last week lecture or not? Or not last week, last Tuesday, yeah, last Tuesday. Anything you want to check with me? Okay, if you start trying to do these assessment, maybe you will find yourself a bit headache. You get headache 头痛吗？头会痛头痛就对了，恭喜你，你走对了。You are on the right track. Yeah, I'm not laughing you or what. You are right on the right track already. Because why? 为什么你头痛？ Because you are using brain now. Okay, you are using your brain now. Okay, this proves that you are thinking. Okay, usually our system of education don't make students think. They just copy paste. That's all. Okay, so try and think. Okay, I know it will be hard for you for this 15 weeks, but after the 15 weeks, you will see this world completely different if you go through this path. This is what I can assure you. Okay, because I have been headed for 4 years during my undergrad. You can imagine or not? The first year I went to the class, after 5 minutes, I will get lost, completely lost. I also had that in the lecture. I want to get back, I also cannot get back, I want to get back, but I cannot. Okay. But second year, a bit better. I can stay for 15 minutes. Can understand what the lecturer is saying. But surely, when the clocks tick to the 15 minutes, I get lost again. Each year I get better. When during the third year, I can stay until half an hour. Fourth year, 45 minutes. Each year getting better. This is a must go through path, I would say. Okay, unless you are a genius. Okay, but like what I said, I prove to you I'm not genius also. Okay, I learned from basic. I learned from nothing also. I was like you also. I don't know. I come from Malaysia background. I finished my pre-U in Malaysia also, matriculation. Okay, so I don't do any fancy A-level or what. I'm also ordinary person. Okay, but we are introduced by this subject of mathematics. Okay, yeah, try and learn something. It will be very helpful for you. Okay, maybe you will cry. You will cry. Why cry? Hey, my friend, I got a friend, he also cried. He cried during his primary school time. You know why he cried? His mother forced him to go and learn piano. He doesn't know. He doesn't want to learn. He cried. You know piano? 钢琴，学钢琴，然后才艺班嘛，去学才艺班。He cried. Cry? Cry still have to go 吗 ？Asian parents 嘛 ，you cry you still have to go. You still have to go. Go lah. He got the skill. Can you imagine what he did with his skill or not after he graduated? I mean, after he grew up. I met him during his PhD in physics. He studied in University of Malaya, and then he got exchange with not exchange. Actually, it's collaborating with our uni ANU. So he came there for the last 2 years to finish his PhD. So I met him. You know what happened with his piano skill in the end? You want to guess? You want to guess or not? Sorry? You want to guess? In his research, wow. Unfortunately, it's not lah. Maybe a motivation story would say, oh, he got a piano champion. Sorry? The money. Maybe, but not that one. He got a girlfriend. See? You never think about what you can do with what you know, You cannot imagine. This is what I say. You cannot imagine what you can get with your skill, And it will be very helpful at some point in your life. Okay. If you learn. Okay, if you're willing to learn. Okay, now. Since we are here, then we must learn something new for you. And for me. Oh, I am also learning. Okay. Okay, now. Okay, so your brain is hurting is fine. Anyone do gym here or not? Gym. Do gym? Anyone do gym? You know gym? Not gym. Gym. Gym 做 gym 会痛耶。To do gym, what do you need to do? You need to how to make your muscle bigger? Do you know the mechanism or not? Sorry? Progressive overload? Wow, very technical, huh? So you need to tear your muscle first. And then only then your muscle will grow. I also do gym few times and nothing grow. So I mean, what does it mean here? So you need to do it correctly, first of all. Second, you need to stand the pain. Okay, but for maths, I'm the one that come over. 我是过来人. Okay, so please, believe in me. Or believe in me. Have faith in me. Okay, if you don't understand, please come to me and ask. Okay, does it make sense? Okay, so before we start, there's one person I need to look for. Is Xie Changyun here? Xie Changyun. Right, can you contact Munir? Munir is looking for you. You know who Munir or not? Professor Munir? You don't know? 不知道? Can you check your Teams, Microsoft Teams? Yeah, please reply to him. Yeah, he's finding you. Yeah, please check your Teams. By the way, all of you have to check your Teams often. This is how school contact you related to school matters. Okay, Teams and email. Outlook. Okay. Okay. Let's come back to where we stopped last time. Let me bring another thing out again. So this one. Okay. Last time we end our course by discussing about existence and uniqueness problem, right? Okay. So what is the thing that exists but not unique, or exists unique, or it is unique but doesn't exist, or it is both. It's not unique and not existing. Okay, so at the end of the lecture, right? Lydia, right? Okay, Lydia remind us of these existence. Sorry, let me remove this. Existence and uniqueness theorem from what you have learned from ODE, linear algebra. Can you recall not? So I do some screenshot here. Right. So there's a theorem in ODE. What did this one say? This one is from ODE. Existence of uniqueness of solution of a particular solution. What solution? What equation is this? First derivative is equal to some function in terms of t and y. I'll show this bring back your memory. With a initial value boundary condition. Okay, this is an initial value problem. Y0 is equal to 0. And then what does theorems guarantee you? If this function and the first partial derivative is continuous in a rectangle, then there is a interval such that there is a unique solution to this first derivative equation or first order equation. Okay, so this theorem says what? This solution is unique and there is this one solution and it is a unique one. And what else? In this linear algebra, what did you do? How did you solve this ax equals 0 equation? It has a non-trivial solution if and only if the equation has at least one free variable. In other words, what? The null space is non-empty. The null space is non-empty. So the null space is non-empty says what? Okay, if you go through this process, the solution looks like a scalar times a vector. What does this scalar times a vector mean? Any scalars you multiply to the vector will solve the homogeneous equation. Correct? So how many scalars you can put into? Many. How many? Where the scalar live? Where the scalar live? Real number many. So many. So real number is a line, right? That's why you see a line here. Span of this vector. So this line, every vector on this line is your solution. So the solution exists but not unique. And so these ideas actually you have seen before. So you need to collect these ideas together. This is why we do algebra. Okay, so all these are characterized into algebra. Okay, yeah. OD question, PD question. Most of the way to solve, right? If you get one answer, you can use symmetry to solve to get the other answer. So meaning what? You are using algebra also. Yeah, anyone do PD here? This semester? Yeah, few of you, right? Maybe you can see that later. Okay, you get one solution first, and how to get the other solution? Maybe you use some algebra, symmetry, or they call it, of the equation. Okay. Yeah. Okay. Let's see. Should we continue? By the way, I think so far haven't marked your assignment, but at least from the lecture, I can see quite a positive attitude from you guys. What do you think? Do you think the same or not? Huh? Do you think the same or not? Do you agree or not? I'm not sure. The last two, the impression that I get from last two is, uh, I can give lecture until I don't want to finish, or in Chinese we say 意犹未尽. Do you agree or not? Are you online every time? I can feel that most of you, I don't want to say everyone, most of you are online. This is what I don't get from most classes. Yeah, hopefully you guys can. Sorry, what do you say? Yeah, hopefully you guys can maintain because the course will get a little harder, okay, every time. So hopefully you guys can maintain. Make sure how to wake up inside my lecture. How to wake up? Ask me question. Ask me question. Ask stupid question also can. Sorry? Huh? What? What did you say? Say again. What did you say? 10 minutes break, huh? Oh, no, yeah, sure. We will have 10 minutes break, of course, but within the 50 minutes, right? You can disrupt me. Okay, I use disrupt me. Okay, 干扰我. Okay, so my point is to finish my lecture. Your point is to don't let me finish my lectures. Okay or not? Does it make sense? Okay, disrupt me. Please disrupt me. Make sure you understand what I said. Otherwise, I was just talking to the air. No use. Okay or not? Make sense or not? Okay, you pay money, right? Did you pay money? You pay tuition fee? Okay, make sure it works. All right. Okay. So where did we stop last time? Let's recall again. I think we stopped at defining. So let me recall something. Recall what we did last time. So let's recall. So we define LC. Okay, and then we define what is associative LC. Okay, we also define what is commutative LC. Can we quickly say what are these? So what is LLC? Simple term. What is LLC? The what function? Good. A function, very good. So we define an LLC on what? On a set. Good. Let's call it S. So a function from where to where? S to itself. Product set. Okay. S cross S to X. Okay. Some of you have this notational problem. This is very true. Okay. We are learning new language now. Okay. PMX. We are learning new language. Learning new language is hard. Right or not? Let me get someone. 来，那位同学，法医的1992。来，你叫什么名？林宏杰。Where you come from? China, which part? 福建啊。Okay, let's not get 福建。Any Chinese people not coming from 福建？ Nike 啊 ，Nike。来 Nike。What's your name? 延盛。Okay, where are you from? Hunan province. Good. Do you have your own dialect? Can you speak some of them? You don't know 湖南话要失传了是吗 ？Anyone know their own dialect or not? You can. Like, where are you from, Eric? 浙江。来说几句浙江话。随便。Okay. Anyone know? You don't know, right? How do you know? Is it correct? 语气不同。So you see, to speak a dialect, is it new language hard to get or not? Need to learn or not? Need to learn, right? So it's the same here. Okay, we need to learn from scratch. Okay, so people ask this product set the middle one is X or 乘. Is X or multiplication? Okay, it is really the multiplication. That's why we call product set. Product we need to take two together. But what is product set? If you think about the normal product in the number, 2 times 4, you get 8. But x cross x is what? It's just x cross x. But what is x cross x? Define a set. So what we define it is just elements looks like the doubles for it as y, comma x and y, such that x is in x and y is also in x. Okay. Actually, you see this kind of object before, you know. For example, what? R2. You know R2? For example. Okay, let's give some example here. R2. Two-dimensional real space. 中学就看过了. Okay. How do you put a point there? Comma 1, 2, right? Comma 0, 0. Comma 1, 3. Okay, it's similar here. Okay, so the element looks like comma x. Bracket x, comma y. Bracket. Sorry. Let me move this one to me. Okay, so this is a function. And what is associative means? It tells you how to multiply how many objects? 3. Okay. Tells you how to multiply 3 objects together. So for x, if you compose the first 2 first, is the same as if you compose the last 2 first. So these are the only 2 ways you can get compose 3 things. Commutativity is even easier. Okay, it says that if you take 2 elements from the set, xy is equals to yx. Okay. Right. So last time we gave an example. So of zn plus. Okay. So is this operation here associative or not? Yes. Okay. So you think that this is associative? Is it commutative or not? Okay, it's also commutative. So we need to prove it. Okay, we need to prove it commutative. Did you guys learn this in discrete math or not? Did you guys do it in your first year? Discrete math, modular arithmetic. Yes, sir. Any one of you take GE elementary number theory or not? No? Anyone? No? You take once. From who? Doolittle. Okay, good. So I think both these courses should go through this, right? Okay, so we will go through it again. Okay, but we will do it more precisely now. Okay, let's do it more precisely now. So for this class, I want to put a bar on top. Okay, I want to differentiate with the normal plus in the integer. Okay, in the integer, we have plus also. So I want to differentiate that. So first of all, if you want to check these two properties, right? If you want to check these two properties, first of all, you need to learn your set first. What does this set looks like? I think we have encountered this in our first lecture. How does this set look like? What's the element there? 0, 1, 2, 3, and so on until n minus 1. Are they just numbers? They are set of numbers. Or in other words, we call it equivalent classes. Okay, why do we call them equivalent classes? Let's say, for example, what is 0 bar? 0 bar has what in here? Sorry? P times n. Is it? So let's give some list of elements here. You want to try? What is in here? 0, obviously. N. Anything else? 2n, good. Minus n, good. Minus 2n, good. So you can go on, right? Okay, so in other words, what are these? These are the number in Z such that B is equals to 0 mod Agree? Okay. So meaning this sentence means what? Congruence means what? B minus 0 is a multiple of n. So then multiple of n. Okay. Okay, cool. So we can replace this. So we can replace, say, I bar. What is I bar? I bar is just all the elements in Z such that B is equivalent to I mod n. Okay. 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 So I think most of you are a bit scared with generalization. So I want to convince you that generalization is good because we can include all the possible ways. Does it make sense? So when you see this kind of generalization, you're confused. What do? You substitute. What are the possible I you can take here? Okay, what are the possible I you can take here? Can you tell me? Can you tell me what's the possible I you can take here? 1, 2, 3, 4, right? I mean, with the obvious one I do for you already, right? 0 also can take. Okay, you can take 1, can take 2, can take 3, can take 4. What if I take n? What if I take n? I do this? Huh? Can, no problem, right? But what do you notice? You notice that this set is equals to 0 bar. Okay. Okay. So meaning what? Meaning what are these? These are what? These n and 0 are called the representative of your equivalence class. So you can pick different representative from your equivalent class. Does it make sense? So meaning what? Meaning I can call this 0 bar, 2n bar. I can call it minus n bar. Also can. I just pick different representative. Does it make sense? Any question? This one is very important because sometimes we will pick different representative, okay, for some reason. Okay. Any question? So I'm trying to refresh what you have learned before. All right. So now we're trying to define addition. Okay. We're trying to define addition. Before that, how do you add 0 bar? How about you tell me an answer? What do you want to get from 0 bar plus 1 bar? Do you have any intuition or what? Can you recall what you have learned or not? Don't tell me how to add first. Tell me what's the answer. Any idea how to add in the Zn? Why? After I change notation, seems like you forgot everything. 1 bar maybe? Right. And then 1 bar plus 0? You mean like this? Commutative. Oh, you mean 1 plus 0 bar. Okay, you are going ahead of me. Okay, let's keep this first. Let's put it here first. How about 2 bar plus 2 plus 3 bar? What did you learn before? How do you add these two? What do you get? Did you get? Intuition. Try intuition. 5 bar. Actually, what do you do? Actually, you are like adding integer. Correct not? Actually, you are trying. You see, it's similar to like integer addition. Okay. But let's see. So let's see. How about n bar plus, okay, let's put this bar on. N bar plus n plus 1 bar. What do you get? 1. Because you know that n bar equal to 0. Okay. So how do we define it? How do we define really? So let's define it. So how do you define it? So we need to relate back what we know about integer here. Okay. So how do we define plus bar here? So for every 2 equivalent class in Zn, so how do we add this 2 set together? How do we add this 2 set together? What do? We simply add their representative. So let me remark here. So we add representative together. And take the equivalent class. Okay. So this is how we define. Can you verify or not? Let's come back here. Let's try. Do we really get what we want? Okay, if we do 2 plus 3 bar. Okay. So this plus here, so let me remark here. This plus is integer, is the normal integer addition. This is what you know how to do. Okay. Okay. So we are adding their representative together and then take equivalent class. Does it make sense? Do you understand what this sentence means? Let me draw a bigger picture for you. So if this 2 looks something like 2 and then 2 plus n and then 2 minus n, right? And so on. And then on the other hand, we have another set, 3 plus n, 3 minus n, and so on, is equals to the set, the equivalent classes of 5, which looks like 5 plus n, 5 minus n, and so on. Okay, so I want to convince you that we really need to define this because we are adding set of, we are not just adding round number, but it appears like we are just adding number, correct or not? So you need to check actually. Okay, so you need to check. So you need to check here. So, so first of all, we need to check that this, let's check that. Check that this plus bar is well defined. Okay, what does it mean by well defined here? I will define for you. Don't be kanchong. Define for you. So that is, it doesn't depend on the equivalent classes that so it doesn't depend on the representative of the equivalent classes we pick. Okay. Why? Like what I said just now, right? If you consider, so for example, if we consider, let's use this, for example, if we consider 0 bar plus 1 bar, we get 1 bar, correct or not? But if we consider n bar plus 1 bar, what do we get? By definition, what do we get just now? We should get n plus 1 bar. Do they agree or not? Is n plus 1 bar 1 bar? You should verify that they agree on the right hand side. Okay, because why? Why? Because we know that 0 bar is equal to n bar. Okay, so you need to check, okay, that the thing that you define doesn't depend on choices. Okay, doesn't depend on choices. Anyone see? Any question or no? Question? If you have question, please ask. Question. Don't be shy, Question. I saw some of you 盯着这样看，应该是有问题的。来，Any question？有问题吗？Don't be shy. Don't be shy. Okay, I give you some more time. Let me continue, and then if you still have question, then ask again. Okay. So how to check? So we want to check that it doesn't. So this is the key point. Doesn't depend on the representative that we pick. Okay, doesn't depend on choices. So how to prove this? So let's give all possible way, right? We can add x and y. Okay, let's consider different representative. Okay. Let's consider different representative. Okay. So different representative meaning they are differ by a multiple of n, right? Agree or not? 0 and n, 0 and minus n, same in the same set. So they are differ by a multiple of n. Okay. And then what we want to show? Okay, we want to show that. So here is our goal. Goal is very important. Whenever you lost, please find your goal back. Okay. So we want to show that x bar plus y bar equals to x plus kn bar plus yn bar. Okay, we want to do this. Once we prove this, we will show that our addition, special addition here is well defined. It doesn't depend on choices of representative we pick. Okay. Note that we do for all integer. So we check all cases already. Okay. So let's pick one of them. So note that, hey, want to show two things are equal, how to do? In this course, you always show two things are equal. Looks a bit different, but they are equal. So what's the strategy here? What's the easy strategy here? Alright. So here, answer already told you already. Who equals to who? The task given to you is to say why they are equal. Okay. So you know where to start, you know where to end. So you need to build the path. Okay. So how to build the path? How to build the path? How to build the path? One way is to build from here. Okay. And then go all the way to the right. The other way, let me draw this arrow here. The other way, you can start from right to left. Okay, I don't know how to draw the full step, but please view this as a full step. There's a third way, right? Huh? Wow. Wow, this one is advanced. Okay, later, I'll come back to this one. The other way is you can work left a bit and then right a bit. And then you can see that they meet in the middle. Also can. OK 不要一条走到黑走到那边卡了不会做。从另外一边再试试看。Because this is already given where you have to start, where you have to end. Okay, there's a fourth way. Lydia say, suppose they are not equal. You can do that. What is that? What are you using? If you suppose not equal first, you are using contradiction. Okay, you are using contradiction. You can do that also. Okay, but this one is a direct proof. Okay, what I show is a direct proof. Okay. So let's start somewhere. So let's start. Yeah, let's start. Okay, I will do this both way. Okay, let's do this both way. So let's start from left first. So left hand side, what do we get? Left hand side actually is easy, nothing to do, right? If you want to add x bar, y bar together, what you really get? This is just by definition. X plus y bar, lor, that's all. Okay, so the goal is to show the right hand side is x plus y bar. Okay. So let's do right hand side now. So x plus kn bar plus bar plus y plus ln bar. So by definition, what is this? This is simply x plus kn plus y plus yn. And then everything up. Good. How on earth is this the thing inside here is x plus y bar? It's not right. Here x plus y got a bunch of other thing. If k and l is 0, then you are good. But typically k and l is not 0. So obviously they are different. No? Then you see I have no hope already. No? Close the book, go to sleep. How it? Can you proceed or not from here? Can you proceed from here? So maybe I put some bracket on, maybe easier to discuss. Okay, so what we really do is we adding these two integers together. What can we do to this addition? Addition of integer. Right, I gave you a bunch of rules last time, right? You can do. Actually, you don't need to remember all the rules. What I want to tell you, moral of the story is, whatever you do to real natural integer is what you learn in your high school. That's all. Okay, so can you play around with this or not? Yeah. Factor n. How to factor? They are not together yet. Okay, you can do swap. What swap you want to do? What swap you want to do? What kind of swap? K and y, but they are not in the same bracket. You cannot swap them yet. Correct or not? An operation is commutative when they are composed together. But what are you composing now? You are composing two big things. But can you go around with it or not? How? How? Let's do it step by step. I really want you to see what is going on. So I'll try to go slower in my first part of my lecture. Then later, once you get the tempo, we'll go fast. Okay, so how? If you want to swap y and kn, you need to make them in the same bracket first. How to make them into the same bracket? Just what? Just delete? Wait, wait, 篡改啊? I cannot just delete. How to delete? Need to delete by law. What law you can use? Associative. So how to use associativity? Okay, so what can we do? So we can move this bracket, right? Okay, so we can move this bracket such that we get x plus n plus y plus ln. Can we do this or not? Now, what are the three things we treat here? So we have x, we have kn, we have this whole thing. Make sense? Can see or not? Can see or not? Can see or not? Must see. This one, nothing special. Must see. Okay. Okay. But still not together. Still not together. Still not together. So how? Let me add associativity here. So this is using the associativity of the normal integer addition. Okay. So still not together. What you want to see is they are grouped together here. Can you do it or not? Can. How? Associate again. Where you associate again. So what are the three things you see here? Kn, yn, ln. Okay, so you use associativity again. Now they are in the same bracket now. Okay. So this one again, associativity of addition. And then Like what agency you can use commutativity here. Okay. Are we done? Not done, right? Just now we say that we want to factorize this n. Okay, they are not together again. So you associate again. Again. Okay. And then if you want to do factorization, what does it call? What is it called? Distributivity. Okay, distributivity. You get what? N times k plus l. Which way you want to write it? Let's write it this way. And then, is it clear now why is this equals to, where's our goal? Let's put our goal here. X plus y bar. Is it clear already? Huh? Not quite clear. Maybe it's clear already, but we can do it more detailed. What else can we do? What things we can do here? Associative, good. So we associate x plus y together. To see what? To see that this set is really just x plus y plus a multiple of n. Okay, which we know that define the same equivalent class with x plus y. Okay, why? Because the representative are differ by a multiple of n. Okay, hence they define the same equivalent class. Okay, understand? Understand or not? Any question? Question. Very important in this course when you define something if that definition depend on choices, then you need to do this kind of checking. Then you need to do this kind of checking. Suppose you have something equals to the other choices. Okay, if you add it with different choices, do you get the same number or not? Then do you get the same number? Then you need to ask yourself. If they don't get the same number, that means your definition is a rubbish. Okay, it's a rubbish because the same thing compute to a different number. Okay, that's a rubbish. Okay, so make sure you have a well-defined function or definition. Sorry. Okay. Hey, actually, what is this? This is a result that you have seen before. Okay, so this is something from your modular arithmetic, which says that P mod n plus Q mod n equals to P plus Q mod n. Okay, this is what you learned before. Okay, so there's one homework here. I really recommend you to do it. Go back and do. I will give you solution in my lecture note. So try and define multiplication in modular arithmetic. Okay, so define the multiplication. How do you multiply? Okay, inside there. Multiplication. Okay, go back and try. Okay, in my class, I like to ask you to try. Okay, you have to go hands-on. OK， 不是随便做做几题，你以为你会我不会这样骗你的。You have to try. OK, you have to try because when you try you will learn in your own way. You will see in your own way, and then that way maybe is very precious. OK, maybe that's the way that can get new idea, new result. OK, no. So that's why I encourage people to try. OK, I won't give a standard working standard solution, ask you, everyone have to write the same. Okay, nothing like that. Okay, that would deter your thinking. You know what's a growth mindset and fixed mindset means? Growth mindset and fixed mindset. So in our class, we encourage growth mindset. Okay, so you need to think, not fixed mindset. I'm not training you a robot. Now the robot can do better than you already. AI. Okay, so make sure think. Okay, make sure you think. Train your brain. Okay. Yeah. Okay, any other question? Yes, good. Yeah, good. Right. This is the time for 10 minutes break. So let's break until 6:07. Thank you.
就是是 B 吧？对。但是你写这个如果没有书的话也没有用其实。但是我突然发现我刚刚把后面的零六开始了 OB。
对，我在想那整大段我们要怎样放进去？
我已经放进去了。
已经放进去了，因为我怕等下会搞乱他们，等下他们不知道要读还是不要读，到底。我觉得我们可以讨论一下了，慢也再讨论一下。我找一些人一起来讨论一下。
我已经放了，重点在。
没事，你先放先了。你先放先，我们之后再讨论一下，感觉。因为我怕等下搞乱他们。
我刚刚给你上传了一个我改过的版本，除了我的话，得把那个 OB 改回零遍。
没有问题，我们可以一直更新的那个东西，没问题。没事啊，你先打一打，我们再看怎么办吧。好，我们讨论一下啦，因为我也不知道对你们大家什么都最好。他好像差不多打完了，是 lecture 1个啊，1跟2都打完了
，1跟2都完
了。可是那个照片那个图案暂时是用 screenshot， 我是想用 text picture 跟它弄出来，因为如果你有 text picture 的话，以后要改不要弄，不然就等不图。
好，
跟怎样还慢点，我们再讨论再看一下。就之后还会有很多画的东西出来。这样难用？很难用咩？哦，还可以啦，好用啦，其实。是啊，我们画的那个 paper 全部都是用 text picture， 我会这样一条线这样弯来弯去的全部。可以啦 ，I mean， 因为比如说上次他画那个三角形，不是？你三角形只要画出一个你就够。你就调它的 coordinate， 像你讲了，我一个放00，一个放10，放20，放30。呀，可是那个也要自己加，真的，这个是真的。
所以我觉得还不直接做出成图来方便。
对，只是说以后啦，容易改那个 text code。看到我们讨论一下啦，看谁啊？讨论一下。
因为这个 metric 是要写 proof 它是一个 LOC， 然后再 proof 它是 associate。你看，假如我要 proof 这个是 associative， 这样我是不是要 proof A、B 等于 A、B、C 嘛？
没错。
然后你要说两个 matrix 是 equal 的时候，就是说他们的 entry 全部有一
样。
然后我可以直接 define matrix mode， 就我可以用之前的，
没有，就是用之前的，对，没错。
我就不需要再 check for 什么东西。
要 check for 什么东西先？
想看一下。因为这是一个新的
entry，
新的 operation 就是 matrix multiplication。
对，没错。
所以我要
你是几？
因为这是一个 definition 嘛，所以我要去 check 它的。
OK， 可能我知道你乱在哪里，因为这一个只是代表 entry 罢了。所以你应该要说是说当我要乘这两个 matrix 一起的时候，我其实只要告诉你它每一个 entry 长怎样，那就长这样。因为你现在写的乘法是什么意思？你是在说那一个 entry 长这样，一个 entry 长这样
一个 entry。
对，你应该要讲所有的 entry 就是跟这个方面都算出来。对，你没有 quantify 对不对？你没有 quantify IJ 呀，你 quantify 了 IJ 就代表说每一个 entry 就是长这个样子。如果你把两个放在一起，看一下，
我还没有 proof 它是一个 LOC 的，我的 proof 它是 LOC。
OK， 大体是可以啦，只是说，你看忽然间有大写 A， 然后这里又没有大写 A，
因为这个是代表
一个 matrix 对不对？
一个 matrix。
对，我知道你讲什么，所以你应该要 relate 这一个去这一个，对不对？所以你应该要写可能
看看啊，怎样写这东西啊？应该要写 A 等于这个东西。
哦，就写 A 等于
对，因为你的意思是想说，我把 A 看成每一粒。
看成有 array of entry。
哎，对对对对对对对对对对对，就是这个意思，就是这个，对对对对对对对对对。然后这边也是这样子说咯，因为你这个只说一个 term 是什么，但是你没有很准确地说我是在乘两个 matrix。对，呀，这只是小东西了，让你读起来比较顺一点了。呀，可以说 we define multiplication by specifying the terms in AB，就这个，对不对？
还是我上面可以再 define 就
了解。
用我 define 我的 entry 的 notation as 这样，我 define 这个 A 就等于 A，这个就代表哪一行哪一 row 哪一个 column 的 entry。
可以，可以，但是你能够解释一下这个大 A 跟这两个的关系吗？大 A 跟这两个的关系，
讲大 A 跟
或者说，我觉得应该够了吧？我觉得，那这个呢？这个是什么东西？
这个就是一个 matrix of。
对，但是你没有，因为你看啊，你假设define这个 as your matrix 啊，但是你又用大 A，不是很 confusing 吗？你不是应该要放括号 Aij，然后括号 Bij，括号是不是？所以你要解释哦。
我要解释这个写的东西，
其实就是这些东西哦。所以我就刚才说我 suggest 啊，可能如果你我不知道你怎样 arrange 啦，但是如果你要这样的话，你应该要这样 A 等于这个。
A 等于这个。
then 我就可以用，我又可以用这个，我又可以用这个。and then 就是说这些顺序你要讲好来，你这样呀。我当然知道你到底要讲什么了，就是说要写清楚。呀，包含这些这样子的小东西。
可以，可以，谢谢。
你讲这些小东西了。Okay, let's take attendance. Is Pang Xiaoyang here? Pang Xiaoyang. Pang Xiaoyang, did you notify Pauline about your calculus 2 enrollment? Did you? Because she hasn't added you into the list yet. You try and ask her again. Okay, thank you. Ling Hongjie. Okay. Lu Ziming. Yeah. He Jingyan. Yeah, this guy, I think I need to check out. This guy not here. Zheng Zihang. Yeah. Adrian Tan. Tan Jialing. Gu Zixuan. Yeah. Lydia. Yeah. Jialing. Yeah. Xiaoqi. Yeah. Eugene. Yeah. Jasmine. Where's Jasmine? Okay. Albert. Okay. Chen Bi. Yeah. 金鱼啊，金鱼也是金鱼 ，really 啊，金鱼，浩瑞，子豪，戴一成，you are 戴一成 ，Are you not here last 2 weeks, 2 times? You just arrived or what? You just arrived here 2 days ago. Is it because of your visa? No problem. You from where? Which part? Henan. Your flight, why is it delayed? Because of the typhoon? You don't know. Okay. So you have no problem, just delay. 疫情。何心怡。 冷秀彤，冷秀彤，李冰夏。Hey, Li Bingxia, you also not here, right? So why are you late? Or you were sick? But you are in Malaysia already? In China. Oh, okay. So you don't have visa problem, don't have result. Okay, good. Okay. So both of you are in right, you guys haven't enrolled into our Teams chat. Okay, can Ro Sing and Sao Ki help add them in. Can you guys who is this? Yi Chen, Tai Yi Chen and Xiu Bingxia. Can you raise your hand? Sao Ki and Roche Sing. Can you help? Can you guys approach them? They are your class rep. If you have any complaint, you can talk to them. 在这听，他们刚来吧。刘小月，刘子涵，对，马宇轩，孙佳怡，王芳瑜，王佳怡，王舒瑶，OK，云溪，叶长云，严胜，姚逸晨 ，Eric，一凡，钟一凡，周雪康平，郭鑫，洪兆胜，appear for a week. Disappear for a week. Pure Meng Chun. Okay. Li Hao Ting. Li Hao Tian, sorry. Li Hao Tian. Li Jingxing. Lin Yi Tai. Oh Xiu Zhen. Hoi Rachel. Hang Xing. Oh, okay. Seng. Yeah. Yan. Zheng Yue. Yeah. Zhao Rui. Jing Peng. Okay. Wei Zhe. Okay. Lin Jing. Yeah. Good. All right. So let's start. Good. Okay. Hopefully, I will cover everything you need for your assignment by today. Okay. By today, I will finish what you need for your assignment. Okay. Good. So we have this LOC, you can put things together, and then how to put 3 things together, how to put 2 things together, okay? And then we're going to introduce one special thing, special elements inside your set, which is called the identity. Yeah, so what does this identity do? Okay, one rule of thumb, okay, in mathematics. Whenever you see this name, you need to think about its original English meaning first. Yeah, let's see. What's this identity? What does identity mean to you? Hi, Xiaoqi. What does identity mean to you? 喂，真的假的 ？I mean English 哦。身份哈。So is your how to say status? Okay, maybe status. Any other meaning of identity or not? Identical, for example. What does identical mean? Yunxi? Identical. What does identical mean? Huh? You don't know? Well, you didn't know. You don't know. Okay, let's find someone who knows. I can't remember name. Ziming. Okay, do you know what identical means? Same. Identity, same. Okay, same. I think these are the two meaning I know about identity. Any other meaning of identity or not? Any other meaning? Same. So let's see what I gave here. So an identity for LOC on S star, meaning you have a set and a LOC on it. You know how to compose two elements inside the set, is an element. Okay, so it's something. It's an element in where? Inside X again. Okay, such that for all X in S, E star S equals to S star E equals to X. So what can you see here? So to talk about an identity, right, it makes sense to link back to LOC. We need to somehow relate back what kind of composition we have to do. So what did you observe here? If you take any element inside your set, you can left multiply with E or right multiply with E. But what do you get? You always get your S back. Okay. Can you see the idea of identical here? So what is identical here? So the S remain. Okay, if you multiply S left by E and multiply X right by E, you get S back. Can you think of any example? Huh? You give me some example that does this. One in where? Integer with what? Operation. Multiplication. Correct or not? 2 times 1 equals to 1 times 2 equals to 2. Anything else? Any other kind of identity you see before? 0, good. 0 in where? Addition. What kind of addition? Addition of what? Real number, good. Correct or not? If you take 2 plus 0 equals to 0 plus 2 equals to 2. So 0 is the identity. Matrix. Okay, you can give some example in your matrix work. So what can you give? What's the identity inside your matrix? So matrix, if you want to talk about matrix, what operation you do? Matrix multiplication. So what's the identity there? Huh? Identity matrix. Oh, so this is a very good reason why we call the identity matrix. Oh. Because it does what identity have to do. Okay or not? So this is the reason why we call this kind of matrix identity matrix. Okay. And let's see, we also give some example on the space of continuous function, right? So what function you compose, you always get back yourself. What function you compose with, you can always get back yourself. Identity function. Yeah, so that's why we call these identity function, right? So let me give me some function from R to R. Do you know what this identity function do or not? Send X to X. Okay, so in your calculus language, you will see fx equal to x, right? Okay, but if you do in high school where you will put y equal to x, it's the same thing. They refer to the same thing. Identity function. So you need to check off. So whenever you see this example, please verify. Verify what? Verify this line here. Okay, does it do the identity? What have to do? Okay, so should we? Let me give you an example. Let me give you an example. Sometimes what I say is abstract for you. So let's prove. Okay, let's prove something. So prove that identity function in the continuous function is an identity. In what set? So this set what we do is with composition. So we need to compose function together. Okay, so let's prove this. So what do you need to do? What do you want to show? Okay, we want to show that this function is an identity, meaning what? We need to check that for every element. Okay, every element inside my set, what do? If I compose identity from the left, from the right, if I compose identity from the left, I get back the original function. Okay, but this equal signs is equal as what? Equal as function. So if you want to show that equal as function, meaning what? You need to check that it agree at every image. Okay, every point in your domain. Okay, so that is for every x in R. What do we need to do? We need to check that f on identity on x equals to identity on x equals to fx. Okay, this is what you need to do. Right, so we need to check. So how many things we need to check? We need to compute how many things. So this thing is obvious already, it's just fx. But these two things is what? Okay, we need to compute it. So let's see. So consider f compose identity x. Remember, how do we define this composition? How do we define it? This is equal to what? F on the identity on x. But how is identity x defined? What do you get after apply identity on x? You get x. So you get fx. Okay, so first equality done. Okay, equal to fx. How about the other one? Identity on fx. Sorry, identity on f and then apply on x. So what do you get? Identity on fx. But what is identity on fx? What do you get here? You get fx. Why? Because fx is just a number, a real number. So identity on a real number, you get back the same real number. Does it make sense? Okay, so all of them equal to fx, then you are good. Okay. So we are done. Okay. Is it clear? You might be a bit weird. I want to check for OF 但是我找不到 function 的影子好像。I didn't write something like fx equal to x plus y, x square, nothing like that. This is exactly the power of abstract algebra. We don't need to go explicitly how the function looks like. We just need to know how the function apply on x. I just look at the image of x. Enough. Remember our goal, you need to always remember our goal. Our goal is to show what? For every x in R, f compose identity on x is equals to identity compose of x, composed with f, apply on x equals to fx. And this is what we check. Then done. That's all. We don't need to go explicitly how f looks like. And sometimes we do, but most of the time we don't. It is to show a general property. Does it make sense? Okay. Any question? Very important. This is a step you need to get across to understand abstract. Otherwise, you will get stuck only. Why don't want to consider a specific f? Why don't want to consider a consider? Then you get stuck. You stuck inside your own world. No people will understand you. Okay, so please get out from here. Okay, so this is what we show here. Okay, you need to always ask yourself what I need to show. Okay, sometimes we need to get into specific f, sometimes we don't. Okay, you need to ask yourself what we need to show. Okay. Okay. Is everyone good with identity now? Okay. Okay. So let's prove one proposition, and then before we go to a new definition. So remember, we like to know about existence and uniqueness. So what we can show here is the identity element in C star is unique. Okay, and I want to add a word here. Be cautious, if it exists. Okay, it might not exist inside your set, but if it exists, it is unique. So that's why I put the identity function element. Okay, if it exists, it is unique. Okay, so like test you. Okay, so to show something is unique, what do you need to do? Yeah, assume there's another one. Okay, so take two identity elements that do the same jobs. Okay, that do the same job, but I give them two different names. Let's call them E1 and E2. Okay, let's call them E1 and E2. And what do we want to show? Go. Quickly say what is our goal here. What do we want to do here? Want to show that E1 equals to E2. Good, very good. Right, how to show this? What time? Let me give you 2 minutes. Talk with your friend. Can you try it out? Talk with your friend. How to prove this? E1 equals to E. I discuss. Talk to the friend beside you. Yeah, try and show it. I give you 2 minutes. Try to make some friends. Friends is important for you to finish my assignment at least. Yeah, try to make some friends. Yeah. 这个情况2个都有。已经解决了1乘 x 等于1 2乘 x 方。为什么1的是？对。Okay, any idea? Any idea? Any try? Any brave solve? Want to try? Brave solve? Want to try? Excuse me. Anyone finish this proof? Want to try? Don't be shy, I can check for you, personally now, Hey, like what I said just now, I want to show 2 things are equal. 3-way at least for direct proof, right? Left to right, right to left. Left a bit, right a bit. So My choice now is go from left first. Start from left first. Okay. I want to start from left, and then I want to end with right. Middle have to put what there? This is the main problem now. Okay, what can I do? Can I do anything or not? There are really, here got two obvious things you can play around, right? Play first. Okay, no matter what we get, play first. Experiment first. Try first. Experiment is very important. I realize when we go through high school and high school mathematics, usually teacher will tell you everything until the end. So you no need to figure out. 不用想了，老师讲做就是这样，答案就出来了。But in here, I want you to experiment. You know what experiment is? 实验. Okay, try some combination. Okay, so there are two obvious things here. Can you try and compose them together? Right? We do some experiment. Can we try experiment? Can we try put them together or not? What do you get actually? You might get E1. Why? Same. What property you are using? Who is identity? There's a name, right? Because what? Because E2 is an identity. Okay, good. Any other possible answer you can get? It is also equal to E2. Why? Because E1 is an identity. Not just E2, E1 is an identity, right? When we say that we take these identity elements, they are coming from X also. Okay, so you can use your definition here. Okay, you can use the identity definition. Okay or not? Okay. I like algebraic proof. You know why? Because algebraic proof usually the answer will drop out from the definition. You don't need to construct. If it is analysis proof, most probably you need to construct something. Is it true? For example, if you want to prove an epsilon delta proof, you need to produce a delta. You need to produce maybe an capital N for your epsilon. You need to find. But is it the only delta that work? Is it the only N that work or not? No. The answer is not unique. Depend. Maybe it depend your epsilon. Okay. Depend on the choices you take. No. But algebraic proof, typically we just play from definition. So this make definition really, really, really important. Okay. You need to get familiar. First time in my lecture, blur is okay. Go back, do revision. Still blur, come to my office hour. Okay, still blur, read again. Email me, message me, disturb me. I don't disturb too much. Office hour, okay. Office hour, okay. Okay. Yeah, you need to rest. I also need to rest. Okay, weekend. Okay, so what can we do here? So what do we put? What should we put here? We can put E1 equals to E1 times E2. And then follow the argument that we gave before. We know that E1 times E2 is also E2. Can I do E2 times E1 or not? Can, right? Okay, because as an identity, you have the property that when you multiply from both sides, you get back the original element. Okay, so you can also use the other method, E1 equals to E2 times E1 equals to E1. Sorry, E2. E1 is useless. Okay, now. So you might see the similarity here with your assignment question, but in assignment question you are more restrictive. Then you will see why the question is set like that. Find out. Okay, similar idea. Okay, So, but anyway, if you met a problem with your progress, just come to the office hour. Okay, next thing. So, the other thing we will define is an adjective. Okay, adjective to an element. So, what's this adjective here? An element X in S is invertible. Okay, invertible. I think you've seen this word before. Have you seen this word before? Invertible. Invertible what? Matrix. Okay, good. This is suggesting something similar. So an element X is invertible if there exists another element Y in X such that if you multiply from the right and if you multiply from the left, they are equal. Equal to what? Equal to identity. You get back your identity. Okay. So invertible. Invertible. Let me test you again. English means what? Invertible. 倒转 terbalik. You can invert, so you can turn around. Head to tail, tail to head. But, sorry? Is it? I don't think so. I don't think this is the Chinese translation for invertible. I think they say 可逆. Is it 可逆? Yeah, 可逆. So knee to where? Go back to where? Go back to? Good. Yes, good. Go back to hometown. Why? Because that is your identity. Okay, so you go back to identity. Okay, go back to identity. So go back to somewhere else is not very useful. We have to go back to identity. Okay, correct or not? Is this what the invertible matrix do? You go back to your, if it is invertible, then you can find the inverse such that when you multiply them together, you get the identity matrix. Okay, so I think here you can get a lot of example. For example, let's see in Z plus. So if you have X here, what is the, okay, sorry. So let's give a name first so that we can discuss it easily. So we'll define, so we continue. Then Y is called the inverse of X. Okay. So for example, if you have X inside your integer, what's the inverse? Negative X. Good. Let's give you some tricky one. If I have a natural number, if I look at 0, what is the inverse for 0? Don't have. Someone said don't have. About the other? What's the thing you add to 0, you get back 0? 0 lah. You get 0. 0 is the inverse of itself. Okay? Because 0 plus 0 equals 0. Okay. If I want to write down, because 0 plus 0 equals to 0. Okay, so this 3 things here summarized in this equation. Okay. Okay. So you really need to check this equation here. If you want to check invertibility. What else? How about real number? If I take X, what's the inverse here? If I consider the multiplication. Oh no, X. Do you need to be careful or not? Non-zero. Okay, so we need to throw away 0. So sometimes we will like this, throw away 0. Okay. And sometimes we will denote this whole thing as R plus R cross multiplicative one. Okay, let me see. Did you guys know anything about? Okay, let's do matrix first. I think matrix is more familiar. So when is the matrix invertible? When can you find them? When can you find the inverse of a matrix? So you need to remember your invertible matrix theorem. So if the matrix inside n by n matrix is invertible, only when the determinant is non-zero. Okay. Are you familiar with bijective function or not? Yes, no, yes. Invertible function, inverse of a function. Where did you learn it? Oh, disregard, huh? Okay, I try. So if you want to look at a function inside the continuous function space, when is it invertible? Huh? You can prove that it is invertible only when f is bijective. Okay. So more precisely, I'm not sure you have shown a statement or not. If a function is surjective, you can have a right inverse. If a function is injective, you can have a right inverse. Have you guys seen this kind of statement before? Yes. Some of you, yes. Some of you learn. Let's see. Let's see how we do this. Let's see how should we settle this. Some of you know this fact, some of you didn't. Let's see. How about I give you a, I'll say, okay. How about I want to convince you. Are you convinced or not with this sentence? Maybe you are not. If you are a mathematician, you should prove it before you get convinced. Okay, so maybe I leave as a homework. I will provide the proof of this fact for you. Okay, but you can try and go back and find it, how to prove it. And I will put into my lecture now. Okay, I think it's quite important for you to see now. It will be helpful for your MA, I guess. Okay. So similarly, you can prove that the inverse of an element in S star is unique also. Okay, so this one I left as exercise. Is the same same pattern that we did just now. Okay, so I also want to add one word, if exists. Okay, if it exists. If don't have, never mind. I mean, what I want to say is, if you're set, if you can compose together, if there's no identity, then nothing is, there's no element that did the identity job. For example, correct or not? I mean, in real number, right? Just now, right? If you just consider the whole R, okay, without throwing zero, then zero don't have inverses. So that's it. Don't have inverse. Okay, there's no way to get from zero to back to, what's the identity here? 1. There's no way to get from 0 to 1, for example. Okay, yeah, it's okay. Never mind. Okay, but sometimes invertible elements is quite useful. Okay. Why is it quite useful? Now I'm going to tell you this very good definition now. So this comes to our main topic in our course, which is called a group. A group. Group, you know, right? Group. One group of things. Okay, a collection. But this collection is special. Okay, that's why we call it a group. So a group is what? First of all, it is a set. Okay, we start with set. And then, obviously, we learn so many things about LLC. We have to involve LLC now. Okay, what kind of LLC we're involving? We are involving associative LLC only. Yeah, non-associative one we don't care. Okay, associative LLC. Okay, let's call it star. Star from G cross G to G. Okay, satisfying field property. Okay, satisfying field property. Okay. First property is about identity. Okay, identity must exist. So there exists an element in G. Okay. So from this line, you still don't know whether this E is identity or not. Okay, it's just something. But if you see I put E here, I'm suggesting the appearance of identity. Okay, so what I'm going to continue to write next is this element here has to satisfy what identity has to do. Okay, so meaning this E is an identity lah, correct or not? Okay, it has to satisfy what the identity is. Second, we require every element here has an inverse, meaning all the element here can be invertible, okay, can be inverted back to identity. Okay? So meaning you can always go back to your identity. Okay? You can always go back to your identity. From everywhere, you can go back to your identity. Okay? Does it make sense? Can you think of human as a group, living as a group or not? Can you think of it or not? In this definition, can you try and think? Does it make sense to be this kind of group as a human or associative? When three of you talk together, no matter how you guys talk, it's the same talk. Yeah, no? Okay, it doesn't depend whether you talk to what. 子轩、潘行，潘行，子轩、潘行，Howard. Pan Sing and Howard talk first. And then they talk with Zixuan. Sorry, Zixuan. And then maybe Zixuan talk with Howard first. And then you two talk with Pan Sing. Right? It's the same talk. 没有隔，没有悄悄话，大家都知道在做。Okay, and then identity, maybe it's the guy that everyone that talk to him also can feel themselves. And then inverse, maybe if you talk to the other guy, actually you guys can go through this identity first. Always come back to this identity person. Okay. We have one person to come back. That's why I said this class rep. Everyone can go through him and come back to me. Maybe I'm the identity here. Okay, no? I let you be yourself. Yeah, no? Very interesting. Yeah, try to think about this. Okay, there's some really nice how to say philosophy or idea that we mathematicians want to realize in this world. Okay, we want to make this world a better place. Okay, so to check, I should check something is a group. What property you need to check here? There are a few property, right? One thing is associative LLC. Second thing, you have a identity. Third thing, you have inverse. Okay, so this is the first definition that include multiple property that you need to remember. Okay, what you need to know? A group, you have a set, associative LLC. Second, you have a identity. Third, every guy has a inverse. Okay, you check. So, right, let's define another thing first. So we said that we have commutative LLC, right? If a group that you have a commutative LLC, what do you get? This is what we call the abelian group. We call this abelian group. Okay, abelian, this name is taken from a mathematician called Abel. Okay, so in mathematics, there's a prize called the Abel prize. Okay, this is given, this is set by this Abel mathematician. Okay, and then I think he has research in group theory, I guess. So that's why he has some contribution, okay, in this area. Okay, Abel. So this is a mathematician guy. So in mathematics, if you see a name with some adjective here, we typically don't put capital letter already. Okay, we will put small letter, abelian group. If the property is named by the name, then we will put capital letter. For example, what? You guys seen any property that name after a mathematician or not? I cannot recall in my mind now. Maybe next time if we met this kind of adjective, I'll tell you again. Okay, but here abelian is a small letter because we add some how to call this suffix to the name. Okay, suffix, prefix, suffix, postfix. Yeah, suffix. Okay, put the IAN. Okay, so let's test. So let's give you some example. So for example, Z plus form a group. Form a group or not? Let's quickly discuss. Does it form a group? You have identity or not? Is it associative or not? Do you have inverse or not? I just now we discussed already, right? Is the LOC commutative or not? S plus Y equals Y plus S. So this is not just a group, this is an abelian group. Okay. What else? Give you another number system. For example, the Zn that we discussed just now. Is it commutative? You need to prove with the definition I gave you. So it should be commutative followed by the definition because we define definition of this addition by what? Equivalent class of addition of integer. Addition of integer is already commutative. Okay, so you can check. Okay, you can try and prove yourself. This is also an abelian group. What sort of group is abelian group? So for example, just now, right, we have this R cross here. Okay, if you consider the, let me remind you again, the non-zero real number, okay, where you multiply them together. This is also a perfectly good abelian group. Okay. What is not abelian here? So for example, if you consider a subset here, so consider a subset of function inside your continuous function. Okay, so what's this notation here? So what I do here is this one is the injective. Okay, we will use this hook. So like this. And then the other one is surjective. Yeah, surjective means this double headed arrow. Okay, like 正中红心 surjective. Okay. So just now we said that if a function is injective surjective, meaning what? This function is invertible. Then this will form a non-abelian group. Correct or not? Last time we discussed, right? Composition of a function is not commutative. Remember the counter example we gave last time? It's not commutative. The fx, gx we gave last time. Right? Let's say if you try fx equal to x plus 1, gx equals to x squared. Do they commute? Try and compute. They don't. Okay. Last time we did it, last lecture. What else? There's one very important example in mathematics. It's called the GLNR inside MNR. So what's GLNR here? I will define for you. Don't worry. So this is what we call the general. I'm not sure you use this term in your linear algebra. No. General linear group. Okay, so how is this defined? This is simply the set of n by n invertible matrices. Okay, so is this a abelian group or not? No, right? Because we showed that matrix. Did we show it? We didn't, right? Yeah, we didn't. What I didn't do, you need to be careful a bit. Maybe it might be come out in your exam. Okay, so this is a non-abelian group. You should convince yourself why this law of composition is not commutative. So what can you observe here? You can observe here, if we have a set, we have a if we have a set, we have a LOC. How do we make it a group? We simply consider the set of invertible elements. Those are not invertible, I throw away. Then automatically all of them have inverse. And then you need to make sure your subset has identity. That's all. And make sure that your identity is also invertible. But I think you should prove it in general that an identity element is invertible. You can prove it in general. Correct or not? So I'll try and prove this. So let me claim this. So prove that the identity element of a set is always invertible. Okay. If it exists, then it's already invertible. Okay, in general. Try and prove this. Yeah, try and think about this. I think I will include this proof also in my lecture notes so you can check. Before we back, let me finish one more definition. So I want to discuss about this closeness. So let me define this closeness here. So to discuss about this closeness, what we do is let's take a set and a subset. Okay, so you can see that here there are two cases we are taking subset, actually three cases we are taking subset of something. We will say that the subset H is closed. So mind you, this close is an adjective. Adjective from where? Subset. So to talk about subset, you need to start with a set first. Okay, so this is the setup. So that's why we have the first sentence. You have a set, and then you have subset, and then you define what is closed set. Okay, what is a closed set is? So a subset H is closed under star. Okay, so we put all these things together. If for O, A, B, H. We also have A star B in. Okay, so meaning what? If you look at everything in your subset, you compose them, it stays inside the subset. So I'll give you one last task before we back. Not task, we have to finish here. So can you think of a set that is not closed? Give you 1 minute. So figure out a set which is not closed under star. What is star? Star is here in the assumption. So what is G comma star? Why we put like this? This is what notation? Meaning what? Star is a LOC of the set. Okay. So can you think of a set that is not closed under some LOC? Finish this before you can go. 来，想不出不可以回啊。想不出不可以回啊。Yeah. And then lecture number. So what's your set? So this is a subset of which set? Okay. 除法. Yeah, we will mention about the 除法 next time. How about 不乘法? 不乘法 and then uh, 除法 is a bit sensitive and we don't like 除法. We don't like 减法 either. We only like addition and multiplication. Why? Because we realize subtraction as the negative, and then we realize the 除法 or the division as the inverse in the multiplication. Okay. If I 变乘法还做得出吗？好像不能。That's easy one, very one easy case one, very easy, no need so difficult. And then set of irrational function numbers in this the same set, multiplication, and then you want the irrational number, So how do we draw irrational? I think typically people write like this, real take away the rational. And then why is it not close? You need to give a counter example, right? So you need to show that there exist two things that you multiply, it is not in H. So what are the two things that you multiply is not in irrational? You can take square root 2 times 1 over square root 2, which is equals to 1, which is in rational, so that it is not in the irrational. Yeah, good. Okay, so here is a counter example. Okay, you can think of more, not just these, you can think of more actually. Okay, any question before we break? Sorry, before we finish, I seriously don't want to finish. Okay, before we finish, any more question? Any question before we finish? No? So for now, I think you get every tools you need for your assignment already, so you can start doing it. Okay, so we will see how it goes. So when's your first deadline? When is sir? Second. So when is it? Next Wednesday, I said it can be extended, right? Friday. We'll see how. If you can try and finish before that, then it's good. If not, you can. But we'll see how. We'll see how, because we will still meet on Tuesday, right? So we will have time to discuss if any emergency. See you next week.
怎么知道这个的也有这么多的颜色的？
等一下，让我暂停一下。什么叫做这么多颜色呢？拜拜。